Welcome to the Explainer. Today, we're going to do something the source material brilliantly calls mathematical brain surgery. Seriously, if you've ever stared at an algebra equation and felt your eyes just glaze over, you are absolutely in the right place. We are going to master linear functions, but we're doing it by ripping abstract algebra out of the textbook and dropping it right into everyday reality. We'll take something you already understand perfectly and map it directly onto the math that trips people up on complex exams. Okay, so here's our roadmap for today. We're starting with the taxi logic, then moving into the formation rule, visualizing it all on the Cartesian plane, learning how to discover the hidden rule, and finally, decoding real-world applications. It's a straight shot from a simple analogy to effortlessly solving those tricky exam questions. Let's get into it. Starting with section 1, the taxi logic, inputs and outputs. To really anchor this math, we need to start with a universally understood scenario, something almost everyone on the planet has done: paying for a taxi ride. If I were to ask you right now, hey, how much does a taxi ride cost? Your answer is instinctively going to be, well, it depends. And you know what? That "it depends" is exactly where we discover the core mathematical concept of variables. The price isn't random, right? But it's also not static. It depends on something very specific. Think about it. A taxi ride is essentially made up of two distinct parts. First, you've got the fixed rate. This is that unavoidable entry fee you pay the exact second your seatbelt clicks. It literally doesn't matter if you travel one single block or drive all the way to the next city, that fee is locked in. Then you have the variable rate. That's the price per kilometer, and that is the part that fluctuates depending on how far you actually travel. What's genuinely fascinating here is how this perfectly frames math as just a simple machine. No complicated jargon required. Just think of it as inputs and outputs. You hand the machine an input, the distance you want to travel. The machine applies the rates, multiplying your distance by the price per kilometer and tacking on that entry fee. Finally, it spits out an output, your total price. Input goes in, output comes out. Simple as that. Moving right along to section 2, the formation rule. This is where we translate our reality into algebra. We're going to take our friendly, intuitive taxi machine and rewrite it in official mathematical language. You know, the exact stuff you'll see in textbooks and high-stakes exams. Okay, here is the actual code behind the machine. The classic linear function equation, y equals ax plus b. Let's decode this together. It's really not that scary. Y is just your output, the final price of the ride. X is your input, the distance you traveled. A acts as our variable rate, the price per kilometer. In math class, they call this the angular coefficient. And B, that represents our fixed entry fee, known as the linear coefficient or independent term. And it's called independent for a reason. It never, ever changes, no matter what X does. This illustrates beautifully how a completely tangible, real-world scenario maps flawlessly onto algebraic inputs and outputs. Let's say our taxi charges a fixed entry fee of 3 reais and a variable rate of 2 reais per kilometer. So our formula is y equals 2x plus 3. If your input distance is 0, you're still paying that 3 reais entry fee. Travel 1 kilometer, 2 times 1 plus 3 is 5 reais. Travel 2 kilometers, you pay 7. Just like that, you have built a fully functional mathematical machine right in your head. Let's pivot to section 3, the Cartesian plane, because what actually happens when we take all these inputs and outputs and plot them out visually? Welcome to the Cartesian plane. The horizontal line down at the bottom is the x-axis. This tracks your inputs, moving from left to right as your taxi travels further down the road. The vertical line is the y-axis. This tracks your rising output price, growing taller and taller as the cost goes up. Every single point on a graph is simply a meeting place between an input distance and an output price. Now, the absolutely crucial detail is the number 3. Look at where our graph actually begins. It does not start at 0. Even at 0 kilometers, before the car has moved a single inch, our line starts at 3 on the y-axis. That perfectly visualizes our independent entry fee. Math teachers call this the y-intercept, but you and I, we just know it as the cost to open the taxi door. As we step through the kilometers, inputting 1, then 2, then 3, our points trace this continuous, perfectly predictable climb. Every time we move 1 unit to the right, we move exactly 2 units up, because our price per kilometer is 2. This continuous straight-line shape, that's the entire reason behind the name. That is why it's called a linear function. All right, time to level up. Section 4, discovering the hidden rule through reverse engineering. What if we don't actually know the taxi's pricing rule? What if we only have the final prices of two different rides, and the equation itself is a complete mystery? The source material leans really heavily on this fundamental geometric rule, dois pontos determinam uma reta. 2 points determine a line. Honestly, think of this like a mathematical cheat code. In our taxi context, it means that if you hold just two finished receipts, two sets of inputs and outputs, you already possess all the information you need to completely reverse engineer the entire mathematical formula. So, let's crack the code together. Ride 1 tells us 2 kilometers cost 17 reals. Ride 2 tells us 5 kilometers cost 38 reals. First step, just find the difference. You traveled 3 extra kilometers and it cost you 21 extra reals. Well, if 3 kilometers cost 21 reals, we just divide 21 by 3. Boom, our variable rate is 7 reals per kilometer. We just discovered A, our angular coefficient. No sweat. Now we need the fixed fee, the B. We just take what we learned and apply it backward to ride 1. We know a 2-kilometer ride at our new rate of 7 reais a kilometer should cost 14 reais for the distance itself. But wait, the total receipt said 17 reais. So where did those extra 3 reais come from? That is your hidden entry fee. 17 minus 14 is 3. Just like that, we've unlocked the full hidden rule. Y equals 7x plus 3. Finally, let's hit Section 5, Real-World Applications. It's time to take this newly acquired mathematical superpower out of the taxi cab and apply it to a highly complex word problem you might actually see on a major exam. Here's the thing. Exams are going to try to overwhelm you with massive paragraphs. They'll talk about construction sites, pumping concrete, operative hours, just all sorts of intimidating word problem noise. But don't panic. You are just looking for the mathematical signal. You are just looking for the taxi. Find the fixed entry fee and find the variable rate tied to an input. That's it. Let's look at this specific example from the source. A company charges a fixed setup fee of 500 reais just to bring a concrete pump to your site. Then, they charge a variable cost of 250 reais for every single cubic meter of concrete poured. The question asks for the mathematical expression for the total price Y based on the volume X. And you know what? Once we isolate that 500 real fixed setup fee from the 250 real variable cost, this daunting problem literally solves itself. It just boils down to our familiar friendly taxi structure. Your total output price, Y, equals your variable rate of 250 multiplied by your input volume X plus your fixed setup fee of 500. So Y equals 250X plus 500. See? It's just a really, really expensive taxi ride. As we wrap up this explainer, I want to leave you with this thought. We've just seen how a basic fixed and variable rate governs the cost of a taxi, the price of pouring concrete, and the exact solutions to complex exam questions. This elegant input/output logic is absolutely everywhere. So if mathematical logic governs these systems so predictably, what other hidden rules around you are just waiting to be decoded? Keep your eyes open, and seriously, never let a word problem intimidate you again.